Hey folks, for this screencast, I'm going to talk about my new app that I just built that is basically like Strava. It doesn't have all of the cloud functionality, and it doesn't have any of the the premium capabilities. But if you watched my last video, you heard me explain a little bit about the fact that Strava kind of bothers me because it doesn't give you your current speed. It only gives you an average speed. You cannot plot you cannot get a 3D plot with altitude in it unless you have the premium version. And I find that kind of annoying because, once again, all of the hardware and sensors are on your phone, and you're uploading it to the cloud for Strava to do its own algorithms when you already have the raw data at your disposal. So this app that I am creating is in Android Studio. So I have an Android. So if you have an iPhone, I don't know what you're doing. Get an Android because you can program. Can you program on iPhones? Maybe. Whatever. I didn't have to root my phone to do this. All I had to do was turn on developer options and then plug in my phone and flash this code to it. I would say 80% of this code is from ChatGPT. I went into ChatGPT and said, hey, how do I get the latitude and longitude from my phone? And I have that right here. I have this location listener and location manager. Again, this is all from chat. I'll post the link to my GitHub if you want to download this. I think this is using API 26. That says 36, but I don't think that's actually true. I think, let's see, if I go to settings, appearance and behavior, version control, no, plugins, build tools. I don't actually remember. Ooh, I know how I can find this. If I do a new project, and I do an empty views activity, I'm doing API 24. It says 97% of devices will run on API 24. I'm using Java API 24, so I know I think it looks here like they're already in API 36, but whatever. I'm using 24. So I asked Chat just to give me a location manager and a location listener. I was kind of messing with the accelerometer for a bit, just for fun, but I'm not actually using it in this code. But basically, I grab the latitude, I grab the longitude, I grab the current speed, and multiply that from meters per second to miles per hour, and I get the current bearing. But I actually do more than that. So in the compute function, so right here in the compute function, what I actually do is I convert that latitude and longitude to miles in north, south, and east, west. And I actually compute the velocity. The GPS will automatically give you velocity, but I thought it'd be cool to compute the velocity myself. So I compute the distance in the x direction. Sorry, x direction is north, south. And I also compute the position in the east, west, the y direction. I compute the velocity in the x and y directions, and I also compute the bearing. So I have the GPS give me my heading, but then I also compute it myself, and then I also compute the distance traveled. So if you go over to the activity main, when you run the app on your phone, you'll actually see the current time. Right now I'm just using the time from my phone. Like right now I'm just using, let's see, start time. I'm just using system current time. But again, this is the world of sharing code. So I have this app on here that gives me the current time with my phone, but you can take my code and change that to UTC and have it output Zulu time instead, or even have a text box where you put in your time zone and it will give you your time here wherever you are. But right now it gives you your time just using the phone, the current latitude and longitude. When you hit the start button, it will take your starting location and call that your latitude and longitude origin, so that those will not change. And then it will compute your x and y position and your x and y velocity based on your position from that origin point. And then it computes your velocity. I'm also grabbing the speed from the GPS itself. I'm also computing the distance traveled, the current bearing that I'm calculating using that ATAN command. and then I'm also getting the heading from the GPS. And so while you're running this app, if you're going for a run or you have your phone on your dashboard on your bike, this is real-time data that is not using the internet, is not using the cloud. All you need is a valid GPS connection, which again, you just need the GPS, you just need the skies to be clear for you to get GPS satellites. So I don't have to pay for a subscription. I don't have to download an app from the Play Store. This is my app, and I can change this to how I see fit. One thing that I just realized is not in the code is the elevation. So I don't have the elevation in here, but I could easily add elevation equals location dot get altitude, and I could add the altitude in there, and all I would have to do is add up in here where the latitude is. I would just have to say public double elevation equals 0, and now I have the elevation in there. Now, what I really cared about as well is I also wanted to log this to a data file. So not only are you getting this real-time data that's outputted directly to your phone screen, but at least in API 24, you can actually log to the, and let me see if I can find this. This is logging to the file folder /storage emulated 0 documents. So if you go to the documents folder after you finish your run or your bike ride or whatever, it will create a log file, and in this case it's log 0, so it's like log plus a number, and it will create a log file that you can then post-process later. So I just went for a quick skateboard ride, and it took me 15 minutes of skateboarding, but I have it right now logging data at once a second, I think. Yeah, my log rate is 1 second. And so in Tony over here, you can see here's 30 seconds of data. And what I'm logging is the time, the latitude, the longitude, the origin of the latitude, the longitude, the X and Y coordinate, the distance traveled, the VX, VY, and V display. So Vx and Vy are the velocities in the X and Y direction. That's the velocity calculated. That's the speed from the GPS. And then I have the heading in degrees that's calculated and from the GPS. Now, if you remember my last video, the Strava file that gets uploaded to the cloud is a very insane XML file that was really hard to parse through. Again, since I'm writing my own Strava app, I can make the data file however I want. So I made it a text file just with commas. And so time, latitude, longitude, origin, and then the X and Y values there. And so it's a very easy file to read in. If I wanted to plot, say the heading as a function of time, let's see, all comma 0. Let's say heading is data, all comma, I have to count the columns. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it'd be 12 and 13. So 12 would be the heading, let's see, that's calculated. So this will be calc heading. And then the GPS heading would be data of all comma 13. And then I can just plot time comma the calculated heading. And then I could also plot time and the GPS heading. And then I can throw a grid on there just for kicks. I could throw an X and Y label as well, but that's not the purpose of this video. The purpose of this video is to just show that this app exists. There's my heading. You can see that the GPS heading is a lot quicker and a lot more accurate. Well, I wouldn't say it's more accurate, but it's a lot quicker. The calculated heading has to wait until it gets like 2 data points to get a fix. And so you can see here, at least for the first 30 seconds, I was going 260 degrees from the north, which means I was going about due west. And so if I plotted, let's say plt.figure, and I plotted, plt plot data all comma 1 and data all comma 2, that's the latitude and longitude. The second plot that pops up will be I did this backwards. You want to do longitude on the x-axis, latitude. Is that how it is? So it's latitude first. No, yeah, latitude is on the x-axis. No. Latitude is on the latitude needs to be on the y-axis because that's north-south. So there is, I think, let me see if I can do like PLT plot data 0, 2 and data 0, 1 and then do a blue star or like a red square. I think this origin point up there in the upper right is me leaving the parking lot, and I go down the parking lot a little bit and then I go up the road. And so you can see here, like I grabbed one of the GPS coordinates. This is Shelby Hall. I think that little red dot is me here where I hit the start button, and then this was me traversing this way and then going up this hill here. I didn't want to plot the whole video, the whole thing, just for privacy reasons. But I figured everybody knows where I work, so that's not a big deal. But anyway, my point is that I have this app that takes raw GPS data from your phone, outputs it to a text file in plain text that you solely have access to, and you can edit this code how you see fit. Add the elevation. Honestly, I may just do it right now and just throw in, plus a comma and an elevation. Go ahead and add the elevation in there, bam. And so I'll go ahead and push this, and now I've got, altitude or latitude, longitude, and elevation, as well as all of the other things that's in the code. What I'm going to do is I'm going to, rather than coding this on the fly, I'm going to finish this code to plot everything in the data file, and then push this to the cloud so you have the plotting routine, and then you also have the Android Studio code. I will also post that in the video as well. If you have any questions, let me know, and I hope this helps you in the future.